Hi, everyone. I'm Frank Schmidlin. I'm one of the solution architects in the DCX tribe. I'm going to pick up the presentation from one of the Neil earlier slide. Also, I realized that he's removed the spaghetti from his, but basically he was supposed to talk about the spaghetti logic that is plaguing us. And the cause of that spaghetti logic is that monolith that Neil mentioned. And when you develop on a monolithic platform, because of the shared code base and because you have one big system trying to deal with every single problem you're trying to address, you end up with having intermingled logic, spaghetti logic, and you become afraid of changing one area of your solution without impacting other area of the solution. Going to inspire ourselves from the philosophers of ancient Greece, who looked at the ship of King Theseus and wonder if you could take that huge, magnificent ship and replace one plank and yes, another plank, and keep on replacing plank after plank for 1,000 years, whether that ship remained the famous ship of King Theseus. And putting aside the philosophy behind it, we're going to inspire ourselves from that methodology. We're going to break a monolith down into individual planks that we can replace and re-implement bit by bit without our customers being aware of the change. Unfortunately, we don't have 1,000 years to achieve that. We got about 3. So it's a thing. So we need to move something from that monolith, but by definition, a monolith is not made of individual component. It's one big thing. So we need to break it down, but it's not as easy as simply pull a component and replace it. We need to identify a logically independent area of the solution that we can re-implement individually, separately from each other, ideally in parallel, without impacting other area of the system. So one way we can slice a monolith is along those journeys that Neil mentioned earlier. The logic and the screen and the presentation layer that we use to onboard a customer is quite different from the logic we use to discover a product. So as we re-implement away from the monolith, we can be comfortable that if we implement those areas separately, we won't thread on each other's toe. We can also slice along the architecture layers through the monolith. The front end, the back end, the business logic, again, logically are distinct from each other. They might not be on the monolith. That's the source of our problem. We might have a shared code base, but as we move away from it, we should be able to re-implement those areas of the monolith independently from each other. And finally, we're going to apply what's known as domain-driven design, as documented by a guy called Eric Evans. So I recommend the bottom book, the red book is much better implementing domain-driven design. Put succinctly, domain-driven design is about looking at your huge problem, all the problem that your organization is trying to deal with, and try to identify individual problem within that big problem, to find areas of concern where you can draw a nice line on a whiteboard and clearly say, when we talk about X belongs within that problem, and when we talk about why it doesn't. So instead of trying to look at the entire problem of your organization, you break it down into small individual problems with clearly defined boundaries. And then you organize those problems along 3 types of subdomain. You look at your core domain, the thing that is very specific to you as an organization, the things that differentiate you from your competitors, your bread and butter, your unique selling point. That's what you want to be doing. This is where you want to put your effort, your brain cell, your energy. And at the other end, you've got generic subdomain, things that you need to do them well. But in no way do they differentiate you from your competitors. In many ways, you're better off entrusting other organizations to treat those generic subdomain as their core domain and let them specialize in solving those problems and then consume their solution to those problems. Everybody has to be good at something. You decide that other companies are better at dealing with those problems. And then in between, you've got something called supporting subdomains, things that are important to what you're trying to achieve, but not directly. So you need to do them in order to meet your core requirement, but in themselves, they don't make you money or don't differentiate you. So here at Very, what's core to our business is those customer experience, the way we want to take our customers through our product offerings, through our financial offering, those frictionless shopping experience, the pink user interface, all those things that differentiate us from other e-commerce retailers. Underneath that, we're doing a lot of things that everybody else in retail has to do. We have a content management. We need a way to manage the images and the text we display on our website. We need the ability to search, typing a few keywords and finding the exact product that you're trying to buy for your wife. And we need also component of e-commerce, so a product catalog, a shopping cart, a wish list, all these things. They're very important to what we're trying to do, but we don't really want to reinvent those wheels. We're much better off and trusting other companies to give a solution to those problems and incorporate those solutions in our architecture. And then an example of supporting subdomain would be like experimentation and personalization. They are very important to what we're trying to achieve as an organization, but in themselves, our customers don't care. So we need to do them well in order to provide those experiences that we want to provide, but in themselves they're not. So they count as supporting subdomain. How do we replace the plank of our very ship? So if we're going to re-implement those areas of logic that we've identified one by one, are we going to incorporate them into our offering to the customers without the customer being aware of the change? We're going to follow the Strangler-Fig pattern. Very simplistically, you incorporate a facade component between your consumer and your monolithic component. And that facade to the outside world will look exactly like the monolith. So the outside world won't be aware of what's going on below the facade. And as you start re-implementing areas of your monolith on brand new shiny tech, you hide that brand new shiny tech behind the facade. You entrust the facade to start shunting traffic and requests to the new tech. And as we implement more and more of that new tech, as we replace more and more planks of our ship, you shunt more and more traffic to it and away from the monolith until, lo and behold, one day, hopefully before the 3 years deadline, we will have replaced everything behind the facade, and we'll get rid of the facade, and the entire offering will be on brand new tech. Are we going to organize this brand new tech? So as I said, we want to move away from this monolithic architecture. We want a composable architecture. So we're going to target what in retail is called the MAC architecture, which stands for microservices, API, cloud native, and headless. The acronym is very specific to retail, but the architecture would apply to any industry where you're architecting a modern application facing serving customers. Microservices, you will know the term, but basically they are the physical representation of those bounded contexts I've mentioned earlier. If you've identified specific problem with nicely drawn boundaries around those problems, you can start implementing individual application that deal with those problems and only just those problems. Instead of one big monolithic solution trying to deal with every single problem in your domain, you implement individual solution, truly independent application. You treat them as a completely separate application. They've got their own squad, their own dashboard, their own SLA. They might run on their own infrastructure. They've got completely different technologies if you require, whatever is required to meet and solve that specific problem. And this will enable that innovation and that velocity we're looking for, because now you're dealing with individual problem on individual application. You can modify and deploy and do whatever you want with those applications without worrying about the other problem in your domain. You're truly independent and you can start developing in parallel and accelerate your transformation. For them to be truly independent, microservices have to communicate with APIs or event. So APIs or event basically is two services agreeing on a contract as to how they're going to communicate. The contract is going to cover the communication protocol, the error mechanism, but the schema of the data, the content of the data, everything becomes part of the contract, gets agreed between the two sides, and then the two sides can go their own way and implement their solution to that contract. They don't care about the implementation behind the contract. So now again, the two applications remain independent. There's no dependency on technology or implementation, database, nothing. As long as they both meet their side of the contract, it will work. That's the idea. APIs at runtime is one component calling into another component, which creates a runtime dependency. The two sides of the equation, the two sides of the contract must be there for the communication to succeed. A much better way, much more, if you can architect that way, is to use events. Event is the component with the data will fire that data into the ether, well, into your architecture, and not worry as to whether somebody is there to consume that data. And then services that require that data will consume it again out of the architecture as and when they need to, without worrying about when it was created and who by. Which means now the two sides of the contract can work independently from each other. You could almost have a event producing component, fire an event, and then die. And then a bit later, a consuming component consume that event, not worry that the source component is no longer there. They're truly independent, which means they're truly resilient. They can be scaled independently from each other. So event-driven architecture is where you want your architecture to move towards as much as possible. The C of Mac stands for cloud native. And by cloud native, you might have seen that visual before, which is everything that the cloud represents. With on the left-hand side, you've got the old days of on-premise, when organizations like ours would have their own data center, own servers, be in charge of physical security, air conditioning, and electricity. And then the modern cloud, which on the right-hand side is what we call software as a service, where you consume capabilities, generic capabilities, as I described before, entirely as a service behind an API. You do not have to worry about how it is hosted or it is implemented, where it is. All you see is an API endpoint to which you send queries and receive data. That's the Nirvana, software as a service. And in between, you've got all the capability of the cloud. And we want to be on the right-hand side of that diagram. We want to consume either, as I say, software as a service for our generic requirement, but where we build our own architecture, we're going to use things like platform as a service, value-added services provided by our cloud provider. So we use AWS, we're an AWS partner. And we're building architecture on components such as the API gateway. So if we need an API in front of a service, we use we don't build it ourselves. We configure API gateway to expose that API. Our event-driven architecture will use Event Bridge. Again, where all the plumbing of sending and receiving events is done through configuration. We don't have to write specific code for that. We concentrate on what is core to our problem. Step function, relatively modern offering from AWS, which allows you to orchestrate workflows through a set of component and microservices. You can say, okay, run that service and wait for it to come back. And when it comes back, depending on the answer, do X or Y. And then if X succeed, call A and B, wait for both A and B to succeed and then push the data. And that kind of workflow where before you would have to write is a big if and then else statement or have an ESB or state machine somewhere can be achieved entirely through configuration of step function. You don't write the code for the plumbing. You only write the business logic that address your core problem. And then the like of Elasticache and DynamoDB, which are ways of storing data where you need it, without having to worry about the physical infrastructure aspect of hosting data, about clusters, about sharding, about encryption. All this is handled on our behalf by AWS through configuration. And we concentrate just on the data we need and why we need it. And where we build business logic, as much as possible, we're going to use function as a service, AWS Lambda. Again, that means that we concentrate on writing the business logic that address our core requirement. And everything that's involved in actually running a piece of code, invoking that piece of code, making sure there's enough unit of code running at any given time to handle traffic, making sure you stop running it when you don't need to. So once you pass peak, you don't spend money running compute you don't need. The security, the access control, all this is managed on our behalf by AWS through configuration. So for us, cloud native means that the right-hand side of that chart, value-added services. We will not buy a component that runs as a container on a cluster. We want to consume ready-made services without having to worry about the infrastructure. And finally, the H of Mac, because you are composing an architecture of multiple components, you don't want any of those components to try to impose any user experience on your users. You want them to be completely headless, to only consist of data, not have any notion of where in the user experience they fit. and this is very important to us, because we want a core to our domain is that user experience. We want to provide a very experience. We want to meet those accessibility requirements. Therefore, we want to have full control of the presentation to our customers. We want to make the most use of native capabilities of mobile devices. We can only do that if our logic is in the native app, and the component we depend on are just pure APIs. We want to build virtual reality experiences on those devices and the web. We want to do a lot of machine learning personalization, where individual customers will see almost a different website based on prior use of the website or preferences. All this we can only build if we don't have to worry about the component we incorporate in our architecture, imposing any sort of UI. So I don't have no idea where in time I am, but finally the slide I was supposed to give, which is the technology we use. So Neil has already mentioned Ampliance e-commerce tool, Mac compliant SaaS provider of very specialized in e-commerce. We partnered with them because they're very good at what they do. So that gives us the best retail-centered content management service, and the best composable e-commerce component we can get currently on the market, and AWS. So I've mentioned Lambda function, API gateway, all this to use those value-adding services and build architecture on top of this. And then where we write our code, where we build our core component, we're going to normalize on TypeScript. But JavaScript, the typed version of JavaScript, which allows us to be full stack across the architecture. Wherever we build a piece of code, we will be able to use the same language, with the exception of apps where we use Kotlin and Swift, because we want to be able to leverage those native experience. And right now, we don't believe the non-native ways of developing are good enough for at this level. Our web UI, we're using React, again, a JavaScript framework, but we're doing server-side rendered React. So we use like a Fastify to allow us to render those React component onto web pages before we serve them to our customer. Allows us to be very consistent in the experience we provide, regardless of the browser they use, and also allows the like of Google to find our content on our pages without having to worry about dynamic UI. We're big fan of Storybook, which is a UI development platform that allows you to compose your UI based off out of a component library. It allows to make sure if you need a button somewhere to use the same button that everybody, or create your own and make it available to others. Our microservice Node.js, no-brainer. It's TypeScript and runs very well on AWS Lambda. Our APIs, we use OpenAPI as a standard, and because we want to automate all our testing, we use the like of Supertest and Pact to do as much automated testing of those APIs as we deliver the software. And then the like of Lighthouse and Cypress, with very good framework to do end-to-end testing across the entire stack. Distributed architecture requires a lot of monitoring. You build it, you run it, you support it, means that you need to have a visibility of what's happening in your service, but across the entire service stack that led to the call that failed. Elastic have a fantastic offering now, not just log monitoring like they used to, but they do a lot of application performance monitoring, distributed tracing, but also real user management, where you start monitoring your user on the first click on the website. Instead of wondering how they got to the calls that caused a failure, you can see the interaction and how they got there. And then a lot of infrastructure as code. We use Terraform because we want to do not just our AWS infrastructure, but every other component we bring in, if they're configurable through APIs, we can build a Terraform provider or use a Terraform provider to develop and manage that infrastructure through code, not having to go through any user interface. And then the lack of Fastlane, GitLab, Jenkins, all that tooling to provide this continuous integration and deployment and manage our releases. And that's me done.